We already know a little bit about square roots. For example, if I were to tell you that 7 squared is equal to 49, that's equivalent to saying that 7 is equal to the square root of 49. The square root essentially unwinds taking the square of something. In fact, we could write it like this. We could write the square root of 49. So this is whatever number times itself is equal to 49. If I multiply that number times itself, if I square it, well, I'm going to get 49. And that's going to be true for any number, not just 49. If I write the square root of x, and if I were to square it, that's going to be equal to x. And that's going to be true for any x for which we can evaluate the square root, evaluate the principal root. Now, typically, and as you advance in math, you're going to see that this will change. But typically, you say, okay, if I'm going to take the square root of something, x has to be non-negative. X has to be non-negative. This is going to change once we start thinking about imaginary and complex numbers. But typically, for the principal square root, we assume that whatever's under the radical, whatever's under here, is going to be non-negative. Because it's hard to square a number, at least the numbers that we know about, it's hard to square them and get a negative number. So for this thing to be defined, for it to make sense, it's typical to say that, okay, we need to put a non-negative number in here. But anyway, the focus of this video is not on the square root. It's really just to review things so we can start thinking about the cube root. And as you can imagine, where does the whole notion of taking a square of something or a square root come from? Well, it comes from the notion of finding the area of a square. If I have a square like this, and if this side is 7, well, if it's a square, all the sides are going to be 7. And if I wanted to find the area of this, it would be 7 times 7, or 7 squared. That would be the area of this. Now, or if I were to say, well, if I have a square, and that doesn't look like a perfect square, but you get the idea, all the sides are the same length. If I have a square with area x, if the area here is x, what are the lengths of the sides going to be? Well, it's going to be square root of x. All of the sides are going to be square root of x. So it's going to be square root of x by square root of x, and this side's going to be square root of x as well, and that's going to be square root of x as well. So that's where the term square root comes from, where the square comes from. Now, what do you think cube root? Well, same idea. If I have a cube, let me do my best attempt at drawing a cube really fast. If I have a cube, and a cube, all of its dimensions have the same length, so this is a 2 by 2 by 2 cube, what's the volume over here? Well, the volume is going to be 2 times 2 times 2, which is 2 to the third power, or 2 cubed. This is 2 cubed. That's why they use the word cubed, because this would be the volume of a cube where each of its sides have length 2. And this, of course, is going to be equal to 8. But what if we went the other way around? What if we started with the cube, or what if we started with its volume? What if we started with the cube's volume, and let's say the volume here is 8 cubic units. So volume is equal to 8. And we wanted to find the lengths of the sides. So we wanted to figure out what x is, because that's x, and that's x. It's a cube, so all its dimensions have the same length. Well, there's two ways that we could express this. We could say that x times x times x, or x to the third power, is equal to 8. Or we could use the cube root symbol, which is a radical with a little 3 in the right place. Or we could write that x is equal to, it's going to look very similar to the square root. This would be the square root of 8. But to make it clear that we're talking about the cube root of 8, we would write a little 3 over there. In theory, for square root, you could put a little 2 over here, but that'd be redundant. If there's no number here, people just assume that it's the square root. But if you're figuring out the cube root, or sometimes people say the third root, well, then you have to say, well, you have to put this little 3 right over here and this little notch in the radical symbol right over here. And so this is saying x is going to be some number that if I cube it, I get 8. So with that out of the way, let's do some examples. Let's say that I want to calculate the cube root of 27. What's that going to be? Well, if I say that this is going to be equal to x, this is equivalent to saying that x to the third, or that 27 is equal to x to the third power. So what is x going to be? Well, x times x times x is equal to 27. Well, the number I can think of is 3. So we would say that x, let me scroll down a little bit, x is equal to 3. Now let me ask you a question. Can we write something like, can we pick a new color? The cube root of, let me write, negative 64. I already talked about that if we're talking the square root, it's fairly typical that, hey, you put a negative number in there, at least until we learn about imaginary numbers, we don't know what to do with it. But can we do something with this? Well, if I cube something, can I get a negative number? Sure. If I say this is equal to x, this is the same thing as saying that negative 64 is equal to x to the third power. Well, what could x be? Well, what happens if you take negative 4 times negative 4 times negative 4? Negative 4 times negative 4 is positive 16, but then times negative 4 is negative 64, is equal to negative 64. So what could x be here? Well, x could be equal to negative 4. X could be equal to negative 4. So based on the math that we know so far, you actually can take the cube root of a negative number. And just so you know, you don't have to stop there. You could take a fourth root. In this case, you would have a 4 here, a fifth root, a sixth root, a seventh root of numbers. And we'll talk about that later in your mathematical career. But most of what you're going to see is actually going to be square root, and every now and then you're going to see a cube root. Now you might be saying, well, hey, look, you just knew that 3 to the third power is 27. You took the cube root, you get x. Is there any simple way to do this? And if I give you an arbitrary number, if I were to just say, I don't know, if I were to say cube root of 125. And the simple answer is, well, the easiest way to actually figure this out is actually just to do a factorization, in particular a prime factorization of this thing right over here, and then you would figure it out. So you would say, okay, well, 125 is 5 times 25, which is 5 times 5. All right, so this is the same thing as the cube root of 5 to the third power, which of course is going to be equal to 5. If you have a much larger number here, yes, there's no very simple way to compute what a cube root or a fourth root or a fifth root might be. And even square root can get quite difficult. There's no very simple way to just calculate it the way that you might multiply things or divide it.